Hello everyone, welcome back to my channel. Let's deep dive into neural networks. This video will introduce you to the fascinating world of neural networks, exploring their structure, functionality, and practical applications. We'll cover fundamental concepts, delve into the working of these complex systems, and discuss how they used in diverse fields. The neural network structure. First is input layer. The input layer receives data from the outside world. Each node in the input layer represents a specific feature of the data. For example, if you are trying to classify images of cats and dogs, each node in the input layer might represent a pixel in the image. Hidden layer. Hidden layers process the information from the input layer. They extract features and relationships within the data. The number of hidden layers and the number of nodes in each layer vary depending on the complexity of the problem. Output layer. The output layer produces the final prediction or classification. The number of nodes in the output layer depends on the task. For example, if you are trying to classify images, the output layer might have two nodes, one for cat and one for dog. Connection weights and the combination function. Connection weights represent the strength of the connection between nodes. They determine how much influence each node has on the next layer. Adjusting these weights during training is how the network learns to make accurate predictions. Combination function combines the weighted inputs from the previous layer. It takes into account the strength of the connections and sums up to the contributions of each node. This sum represents the total activation of the current node. The sigmoid activation function. Its purpose is to squash the output of the combination function between 0 and 1. This allows the network to interpret the output as a probability. Nonlinearity. Sigmoid introduces nonlinearity into the network, which is essential for learning complex patterns. Linear functions can only represent linear relationships, while sigmoid allows for more nuanced representations. Gradient descent. The sigmoid function's smooth curve allows for efficient gradient descent during training. This means the network can adjust its weights more effectively to minimize errors. Backpropagation. First is error calculation in the backpropagation stage. Backpropagation begins by the calculating of errors between the network's predictions and the actual target values. This error signal is then propagated backward through the network. Weighted adjustment. The error signal is used to adjust the connection weights. The network learns by gradually reducing the error through repeated iterations of backpropagation, making better predictions over time. Gradient descent. Backpropagation relies on gradient descent to update the weights. The algorithm adjusts weights in the direction that minimize the error. This process is repeated iteratively until the network achieves a desired level of accuracy. Applications of neural network models. The first application is image recognition. Neural networks are widely used for image recognition tasks. By training on a large dataset of labeled images, they learn to identify objects and patterns within images. Speech recognition. The power speech recognition systems, converting spoken language into text. Neural networks analyze the patterns in sound waves to understand and transcribe speech. Third is fraud detection. Neural networks are used in fraud detection systems to identify unusual spending patterns and transactions that might indicate fraud. They analyze data about past fraudulent activities to learn how to spot future attempts. Now we will interpret the weights in neural network model. First of all, what is the importance of weight in a neural network model? Weight is a trained neural network reveal the importance of different features. High weights indicates a strong connection, implying those features are more influential in making predictions. Second is feature correlation. Weights can also suggest correlation between features. For example, if weights of two features is consistently high and positive, those features might be strongly related. Model explanation. Understanding weights can explain how a neural network makes prediction. By analyzing weights, we can gain insights into the model's decision making process. How to use neural networks in Python? Several powerful libraries are available in Python for building and using neural networks such as TensorFlow, Keras, and PyTorch. These libraries provide functions for defining network architectures, training models, and making predictions.